14.1, we're going to start a new section about acid and alkaline. First of all, we're going to learn about the characteristic and also the chemical reactions of acid. So first of all, we have to know that where can we find those acid in our daily life. So turn to page 3. So these are some of the daily commodity that we can find in our daily life. So mainly there are fruits, veggies, and also some of the drinks. Okay, so for all these name, okay, the name of the acids, okay, some of them you have to remember, but some of them you just have a concept will do. For example, yogurt, okay, you have lactic acid. Tea, you got tannic acid. Spinach, you got oxalic acid. Tartaric acid in grapes. These actually are not very important, but for these, okay, the white in color and also this one, okay, are more important. First of all, okay, these two are commonly asked in a public exam. So those are ethanoic acid, okay, so ethanoic acid in vinegar and also tomato sauce. Actually, in the tomato sauce, you got vinegar in it. If you go to McDonald's, okay, you'll find that, okay, at the packing, they will have like A01, A10, 0, things like that, okay. So if you heard about that, okay, they say that the tomato sauce, they have different tastes because these are the batch number. If the tomato sauce, okay, they have coming from different batch, maybe the contents of vinegars in it will be different. So therefore the taste, some of them may be more sour, some of them may be less sour. So both of them, okay, they contain ethanoic acid. Okay, better read it by yourself. Ethanoic acid, okay, very important. The other one, very important, is the soft drinks. So when you drink it, you can feel the bubbles effects on your tongue. Those are coming from the carbonic acid. Okay, carbonic acid. So these two, ethanoic acid and carbonic acid, that we can drink or eat in, okay, actually they are weak acid. But later on in one chapter, we'll talk about what is weak acid. So other than that, we also got some citrus fruit. Okay, right now you can see some orange here. We got lemon, okay. But other than these two, we will have lime, grapefruit, okay. So all these things actually they are all belongs to citrus fruits family, okay. Remember, grapefruit have nothing related to the grapes, okay. So these kind of citrus fruit, when you cut it half, you'll find that you have a pattern like this way. Okay, so for these citrus fruits, okay, they will have acid in it. We call that citric acid. But other than that, okay, these kind of fruits, they are full of vitamin C. Vitamin C, okay, the other form, okay, not the other form. Actually, vitamin C is ascorbic acid. So in the citrus fruit, you got two kind of acid. One is citric acid to give you the sour taste. The other one is ascorbic acid. It also gives you sour taste, okay, but ascorbic acid, actually, it is the vitamin C. Vitamin C is a general term for that only, okay. So you got ascorbic acid, citric acid, and also carbonic acid in the soft drinks like Coca-Cola, like 7-Up, things like that. And in the vinegar and tomato sauce, you got ethanoic acid. Then in the lab, okay, what kind of acid we are using, okay? So right here, these kind of acid are more important than the previous slide. So the first one that we have is dilute hydrochloric acid, which is HCl. Dilute sulphuric acid, which is H2SO4. And also we got dilute nitric acid, which is HNO3. Starting right now, okay, you have to get used to the formula for these three acids because every chapters we're going to talk about these acids. But other than that, okay, I want to add one more for you. That one is ethanoic acid. Ethanoic acid, just now we mentioned it already, okay, it is in the vinegar in tomato sauce. But actually in the lab, we also use that as well. So you can find that for these four chemicals, actually all of them, they contain hydrogen. So one of the key points for the acid is when they dissolve in water, they will give out hydrogen. But later on, we'll focus a little bit, focus that part a little bit more for you. Okay, ethanoic acid, okay, is also a little bit weird from the others. If you draw the formula of it, the structural formula of it, you'll find that, okay, ethanoic acid, it is actually like this. Okay, so just remember, okay, the formula for this kind of acid: dilute hydrochloric acid, dilute sulphuric acid, dilute nitric acid, and ethanoic acid. You have to know how to read it. Okay, so Before we move on to talk about the chemical property, first of all, we'll talk about the characteristic and also some of the physical property of the acid. So you can turn to page 4. First of all, for the acid, okay, the taste of it, okay, of course, it is sour. But I'm not encouraging you to taste any of that. Even it is ethanoic acid. Even you know that that is ascorbic acid. In the lab, remember, never taste any chemicals. Okay. The second effect, okay, it will be the second properties of it will be the effect on litmus paper. Remember, litmus paper we got two. One is blue one is red one. Okay, for most of you, you will think that acid is more dangerous. Okay, acid is more dangerous than the alkaline. Okay, normally people would think like that way. Okay, oh, the acid, okay, is very horrifying. Okay, because they are corrosive. Okay, so when the paper turned red, it tells you that it is acid. Okay, so this kind of concept is just for you to memorize. Okay, if you put a blue litmus paper, it turned red. Oh, that one is dangerous. That one is a red. Is the acid one. Okay, but if you put red litmus paper, actually it will remain red. Okay, so to test whether it's acid or alkaline, for acid, okay, you use blue litmus paper to test it. If it turned red, that is acid. So the third property is, okay, that will be electrical conductivity. So if you remember, to conduct electricity, you got two things. One is the localized electron. The other one is a mobile ion. So in this case, okay, if I dissolve the acid into the water, we got the aqueous solutions. This solution, it can conduct electricity. So all of these, okay, we call those electrolytes. Okay, in Chinese, it's called 電解質. So for acid, okay, if they are electrolyte, they can conduct electricity. So you can see the setup right here. Okay, when you conduct electricity right there, the electricity can pass through and complete the circuit to make the light bulb light up. Okay, so all kind of acid, as long as it dissolves in water, they are electrolyte. They can conduct electricity. So how about the chemical reactions of the acid? This part is even more important. You have to know that, okay, acid can react with three different things, okay? First of all, it will react with metal. Not all of the metal, you know that some of the metal they cannot, okay, later on. Okay, so it can react with metal. For example, it can react with magnesium, it can react with calcium, it can react with sodium, and so far and so forth. Okay, but remember, one thing cannot, okay, that is copper. Okay, next, okay, it will react with base. What is base? Base actually is a chemical opposite. Chemical opposite to the acid. So, for example, how can you recognize it's a base? As long as it is a metal oxide or metal hydroxide, then it is a base. Third, okay, it can react with carbonate or hydrogen carbonate. Okay, the carbonate or hydrogen carbonate. So when you are given some of the chemicals, okay, you just try to categorize this kind of chemical, whether they are metal, base, or carbonate. If they are one of these, then most likely it can react with the acid. Let's have a look. Okay, some example down here. So first of all, okay, we have magnesium is a metal, so therefore it can react, okay, with the acid. Copper 2 oxide. Copper 2 oxide is a base, metal oxide, right? So therefore it can also react. Hydrogen, it is not metal, not base, not carbonate. So this one cannot. While this one we have metal carbonate, we have silicon dioxide. Silicon dioxide, it looked like to be an oxide, but this one is not a metal oxide because silicon is a semi-metal. So therefore this one, it doesn't categorize as a base. Okay, and then we have zinc. Again, it is a metal. We have metal hydroxide. Plastic, it doesn't fall into any category, so therefore have no reaction with plastic. And this one is the hydrogen carbonate. Okay, last one, okay, this one, it is not metal, not base, not carbonate, so therefore have no reaction with this. Actually, this one is glucose. Okay, so this is how we categorize. Okay, how can we tell whether it has reaction with the acid or not? By basically find out the category it belongs to. So the first one, okay, our reaction with the metal. You can turn to page 5. General equation for this one, okay, will be metal react with acid to give salt and hydrogen. So just give you some example. For example, we have nitric acid, HCl, H2SO4. Say for example, okay, if you react with the zinc, then you have like zinc nitrate. And also you got hydrogen. What you need to do is just try to balance it. Will do. Okay. So remember the acid, okay, is HNO3. You can consider this one as HNO3. You just consider them as H plus and NO3 minus will do. Remember, don't try when you try to balance it, don't break the NO3 into 1N, 3O or things like that. Okay. Next, for example, we have magnesium adding into the HCl. So the salts that we have will be magnesium chloride, MgCl2. Okay, remember Mg is 2 plus, so therefore it will be MgCl2. And then we got hydrogen. So basically, okay, when you look at this one, you see that 1 Mg, 2 Cl, so therefore the ratio for this one have to be 1 to 2. Okay, and then the hydrogen will then combine. I don't know why my pen was just like broken line like this. Okay. Oh, so the last one. Okay, if we put, let's say, if we have put Fe iron, okay, into sulfuric acid. For example, the product it formed, it may be iron 2 sulfate or iron 3 sulfate. Let's say it's iron 2 sulfate first. So you have Fe2 plus and SO4 2 minus. So therefore the formula of the iron 2 sulfate would be like this. So this one is 1 to 1. So therefore 1 to 1. Okay, if you do like that way, it is balanced already. So you can see that in the process, okay, actually they keep on giving out hydrogen, hydrogen, and hydrogen. So the observation that you can see, the first one, okay, you will see colorless gas bubbles evolve. Remember, never tell that it is H2, okay? Don't tell me that, oh, hydrogen evolved, because you can see here, okay, these are colorless bubbles. They are not having a shape like this. Oh, we are hydrogen, okay? It's saying like that. Oh, it is not like that way, okay? So therefore, you just see colorless bubbles. If you say hydrogen evolved, no mark will be given. Second one will be the metal dissolves. So you find that, okay, this metal, at the end, they become salt, which is soluble in water. So the metal will then slowly dissolve, okay? So remember, try to say zinc dissolve, but not saying metal dissolve. Real metal is too general, okay? You put zinc in it, so therefore no worry. You can say zinc dissolve instead of metal dissolves, okay? Third one, okay, sometimes people will argue saying that, or not argue, they will saying that test tube becomes warm, okay? But in public exam, normally we didn't see this marking scheme. Sometimes we see, okay, sometimes we didn't. So I prefer you to write the one that you can observe with your eyes, okay? So 1 and 2 will be better than the third one. Test tube becomes warm. Actually, it is correct because it is an exothermic reaction. That means heat will be given out. Okay, so that will be the reaction with metal. Next video, we'll do some exercise on. Okay, to summarize these videos, okay, first of all, we have learned about the common acid in our daily life, okay, and also the one in the lab. So for the lab one, is more important, okay, we learn HCl, HNO3, and also H2SO4. Other than that, I also teach you an ethanoic acid, okay, that will be also used in lab. For physical property, they are tasting sour. They can turn blue litmus paper into red, and also because they are electrolyte, so therefore they can conduct electricity. Okay, 3 chemical reaction. We have learned about the first one. They can react with metal, and they will give out salts and also hydrogen. Okay, other than that, they will also react with base and also carbonate and hydrogen carbonate. Sorry, this one should be one word. Okay, one word. Okay, so that's all for this video. Bye bye.